Hi, everyone. Welcome to the June, it is still June, right? June edition of the Journal of Statistics and Data Science Education webinar series. Let me go ahead and share my screen and fill you in on a few announcements, and then we'll get started. Let me put this in slideshow mode. All right, so today we're going to be talking about Think-Aloud Interviews, a tool for exploring student statistical reasoning, with Alex Reinhart, Ciaran Evans, and Amanda Luby. I'll talk about each of them a little bit more here in a minute. I'm Lee Johnson. If you don't know who I am, I'm at Capital University in Columbus, Ohio. I'm the host and moderator, so I'll help facilitate questions and things as we go along. For those of you who haven't looked at the journal in a little bit, we did have a couple of articles that were published in the last couple of days. So one, collaborative writing workflows in the data-driven classroom. Right? Definitely if anybody who's teaching data-driven kind of things, that might be very interesting. And then one that was literally posted, I think, yesterday, a multi-level analysis of the effects of statistics, anxiety, and attitudes on the trajectories of exam scores. So a couple new articles for you to check out there. Next month, we will be talking about integrating data science ethics into an undergraduate major with several individuals from Smith College: Ben Baumer, Randy Garcia, Albert Kim, Catherine Kennard, sorry if I'm saying that name wrong, and Miles Ott. That will happen. It's a slightly different time just because of some logistical issues, but July 19th at 1:30 p.m. So look for announcements of that in the coming days. And this may seem like a weird one to still have up on a slide, but I did want to note that ECOTS happened last month. If you weren't a part of it, or you weren't able to attend, there are recordings available of the keynote talk, so you can go to ECOTS and listen to those. In particular as well, there is a reading group that has started based on Rob Gould's keynote talk. The modern student is younger. So just a little bit of details about that. The general format of the reading group, we're gonna meet 1 hour to talk about the meeting's paper once every 2 weeks. The exception will be, the group is going to meet this week because next week is July 4th week. So this is actually starting tomorrow if you are interested. You don't have to attend each time to participate in the reading group. They're going to look at the 14 articles that were mentioned in Rob Gould's keynote talk. So if you have any questions or you want more information, there is Megan Motko's email address. You can contact her. The first paper they're going to talk about tomorrow is this one from Chris Wild. I can't say that name, but I'm going to let that go and just let the names speak for themselves. Also, if you want more information, if you don't know already, there's a Slack channel for cause. If you go to the ECOTS page, there's a little button at the bottom that says Slack. A lot of these announcements are now going through Slack, so that will help facilitate getting information out, in addition to the cause email mailing list. All right, I think that is all my announcements. So let me just give you a little background on our speakers today, and then I will let them take over. Alex Reinhart is an assistant teaching professor of statistics and data science at Carnegie Mellon University. His work has ranged from spatio-temporal data analysis, I hope I pronounced that correct. Alex, you can fix that for me if I did not, to large-scale COVID surveys, and he is interested in statistical pedagogy and course design. Ciaran Evans is an assistant professor of statistics at Wake Forest University. He's interested in statistical education and pedagogy and enjoys collaborating with other educators on teaching and research. And then Amanda Luby is an assistant professor of statistics at Swarthmore College. She works on statistical methods for understanding complex decision-making and is also interested in statistics education, research, and practice. All right, I believe that is where my sharing stops. Let me just let the presenters take over from here.
All right, thank you for the introductions and for getting us all together today. So yes, we're going to be talking about Think-Aloud Interviews as a tool for understanding and exploring student statistical reasoning. So what we're interested in here specifically is student reasoning. And we need ways of understanding student reasoning for several reasons. So one is just to improve your own teaching. It's useful to know how your students are thinking about statistics and the problems they're solving, the work they're doing. So you might make a better lecture or lab activity or whatever. But also, if you're doing something more ambitious, maybe a new teaching intervention, they're doing a flipped classroom or new types of activities or designing a new curriculum, it's useful to know how students think about statistics so you can design activity and interventions to get them thinking more like experts or more like how we want them to think. It's also, when you do something like that, you design an intervention, often you might write an assessment or a concept inventory where you write questions designed to measure whether this new intervention, new curriculum is working. And to write questions like that and to ensure the questions work well, it's often useful to know how students think about the questions when they're answering them, so that they're applying the skills you intended the question to measure. They're not taking shortcuts using, multiple choice test taking tricks to get the answers, or maybe misreading your question and going off in a different direction. And understanding reasoning doesn't just apply to students. It's also useful often to understand expert reasoning. We're often trying to get students to think like expert data analysts or expert data scientists. But experts aren't always aware of how they go about solving problems themselves, because it's become essentially automatic. And so finding ways of eliciting how an expert approaches a problem is also quite useful. So there are a range of tools available when you're trying to do research, I guess, at reasoning. The first would be, anecdotal observation, like I'm sure you all do. You look at the homework submissions your students turn in, their tests, their lab activities, or whatever, and you look at the answers they provide and you realize, oh, my students must think this, tomorrow I should spend 10 minutes going over this topic. And similarly, you might discuss things with students in office hours or in your class activities or in labs, and just get general impressions of what they're thinking, how they're answering questions, and so on. More formally, you might try something like a concept inventory, or some kind of written assessment, multiple choice questions designed to cover concepts. You might look at the wrong answers students provide, see, what are they getting wrong? But it doesn't give you much insight into how they're thinking, how they're approaching those problems. So to get more detail and learn more about how students are thinking, interviews are a good approach. So you might do like an interview or a focus group with students. Maybe you give them some problems, you start asking them, well, how did you approach this problem? Why did you choose this answer choice? And follow up, prompting them and so on, to get a sense of how they went about doing statistical tasks. And the thing we'd like to talk about today is a specific kind of interview, what's called a think-aloud interview. And a think-aloud interview can provide unique information that's hard to get through any of those other methods. So think-aloud is a method we're developed in cognitive science by Erickson and Simon back, I think, in the 80s and 90s, for just generally understanding how people reason about tasks, not just statistics tasks, but all kinds of tasks. And so in a think-aloud interview with the student would complete the task while narrating their thinking aloud, just as a stream of consciousness, everything they're thinking as they're thinking it while they get to the answer. And crucially, the instructor, the interviewer, whoever is there with the student setting a task, gives no feedback at all. The goal here is to get an unfiltered view of student thinking as they would think if they were on their own trying to solve a problem. And it turns out that often, if you ask people to explain their answers afterwards or to explain their reasoning, they go about things differently, knowing that they're sort of being judged on their explanation. They're trying to order their thoughts in a more clear way. Whereas if you just get stream of consciousness as they're thinking, you get something that's hopefully closer to how they actually approach the problems, sort of on their own, unsupervised. The think-aloud interviews as a technique have often been used for things like designing and revising concept inventories. I've listed a few here, which are concept inventories in statistics, but this has become a technique widely used in a lot of fields like physics and chemistry, where researchers are developing concept inventories for courses in those disciplines. You have students do questions from your proposed concept inventory, find out how they interpret them, make sure their questions work. You can also use this to study expert practice. There's been a variety of studies in different fields. Lovett did one in statistics to see how experts analyze data. And you can use Think-Aloud interviews to identify student misconceptions. Now, before I go on into how we use this, I do want to have one important disclaimer. What we're talking about here is the use of Think-Aloud interviews as a research tool, not as an assessment or a grading tool. One key feature of Think-Aloud interviews, to get an unfiltered view of student thinking, it's helpful that they're not terrified. And so having them not be worrying about their grades really helps in the process. So this is a research tool. And as such, it can fit into your research process in different ways, depending what you're trying to do. In our case, we were working on, our department had developed a new introductory statistics course, a new curriculum, and we were trying to write some questions that would measure concepts in that new curriculum. And so we decided on using Think-Aloud interviews to help us check those questions and check sort of our ideas about what the students were thinking. So we had a process where we would write questions, we review them, revise them ourselves based on our experience with students, and then conduct interviews. Sometimes those interviews reveal the questions were confusing or there are problems. We'd go back and revise the questions. Sometimes the questions would reveal misconceptions that we didn't expect, and we went and said, oh, we should write a new question about that problem. And this sort of led to a process of repeated revisions until we had solid questions that we could then give to the class. But the Think-Aloud portion of this was the key portion that provided sort of most of the insight. And so I'm going to turn it over to Ciaran to tell us more about the Think-Aloud process itself.
All right, can you go to the next slide, please? All right, so in this part of the talk, I want to discuss some of the details that are involved in conducting Think-Alouds as part of a research project. I'm not going to go into sort of all of the specifics here. There's more details in the paper, and there's some good citations in the paper if you want to look into some of the sort of background literature there and best practice advice. But as Alex was talking about, sort of the Think-Aloud process fits into a sort of general research process. And so the Think-Aloud process really begins with a research plan to address a specific kind of research question, as you might have with any study. Certain questions might lend themselves well to Think-Alouds. Alex provided a few examples for you there, and we provide some more examples and references in the paper with ways that people have used Think-Alouds before, in addition to some details on how we use Think-Alouds to do an exploratory study on how students in introductory courses at Carnegie Mellon understand some core statistics concepts. I want to point out that because Think-Aloud interviews sort of involve interviewing subjects, IRB approval or some kind of exemption is probably going to be necessary. And this is the sort of thing you want to think about at the beginning of the study as you're starting to think about how you're going to use Think-Aloud interviews to address a particular question. Could you go to the next slide, please? So once you have a research goal in place and a sort of broad outline of what you actually want to study, the next step, of course, is to create questions which allow you to investigate this kind of research problem. As Alex talked about, the point of Think-Aloud interviews is to capture student reasoning in real time. So interview questions should avoid things like memorization or questions that are too easy or too difficult. Same kind of advice you might give for best practices on writing exam questions too. Otherwise, you won't really get a good sense of what students are thinking. In our case, we were interested in exploring student understanding and investigating whether our beliefs about introductory students and their misconceptions were correct. So we drafted questions about topics like sampling distributions, correlation and causation, the kind of questions and topics that we'd seen students stumble on a little bit in class, and we wanted to investigate a little bit more. Next slide, please. And then once the questions are in place, the next step is going to be to actually recruit participants who will be involved in doing these interviews. Alex talked about this a little bit with talking about research versus grading. A key principle in Think-Alouds is that they should be non-evaluative. So students who are participating shouldn't feel judged. They shouldn't be graded. Any information about their participation shouldn't be shared with the course instructor or any TAs of the course. And that goes into the recruiting process as well. So in our case, for example, we had a member of the research team who was not involved in the course do the recruiting, and none of the course instructors or TAs were involved with any of the interviews or knew any identifying information about the participants. This really ensures that the people who are participating in the interviews feel comfortable actually sharing their thoughts without worrying about how it's going to impact them in the course down the line. Next slide, please. Once you've got students who are willing to participate, then the sort of main bulk of the work is actually conducting the interviews. In the same spirit as having non-evaluative recruiting process, you want non-evaluative interviews, and it's important to make participants feel welcome and comfortable at the beginning of the interviews. So following recommendations in the literature, we recommend doing an introduction at the beginning that helps students understand what the purpose of the interviews are and the purpose of the study, what the interview process is going to look like, gets them comfortable talking to the interviewer. We also recommend using a warm-up question that's not necessarily related to the subject matter that you're going to be talking about. This helps students get a little bit of practice thinking aloud before they actually have to do it with statistics. Thinking aloud, your thought process can be a little bit challenging if you haven't done it before. And we recommend students have a little bit of practice before they actually start doing it with statistics questions. So our warm-up question asks students to describe how they made their favorite type of toast, when they toasted the bread, and how much butter they put on, and so on. We also recommend, actually, before you do any interviews with students, that you try this out with your colleagues and just see what that experience is like. Try thinking aloud yourself and see where some of the stumbling blocks are and what it feels like to listen to someone think aloud without giving any input. We're used to in office hours sort of nodding along as students sort of say something or giving them input, and you really want to make sure to not do that as students think aloud. So having a few practice sessions can be helpful. When you ask questions, you do questions one at a time. Students think aloud their answer as they go, and you really want to make sure that you don't give them any input on how they've been doing on the question. We did a debrief session at the end of the interview so that students who had any questions on the material had the opportunity to ask us that, and we could ask any follow-up questions as well. So it made it a better learning opportunity for the students if they were actually curious about going in detail into some of the questions. We budgeted about 30 minutes for the question portion and about 20 minutes for the debrief at the end in an hour-long interview process. We found that most students ended up going through about 20 questions in that 30-minute window. We gave reasonably short questions. With longer questions, you'd probably get through fewer questions. Next slide, please. All right, I'm going to turn it over now to Amanda to talk about some of the interesting things that we saw when we actually gave these questions to students.
Great, thanks, Ciaran. Yeah, so we are ending with an example from the paper that we think really highlights, the usefulness of Think-Aloud interviews. So here's a question that we've given in our introductory course before. So to estimate the average number of daily hours that students study at a large public college, a researcher randomly samples some students, then calculates the average number of daily study hours for the sample. Pictured in scrambled order are 3 histograms. One of them represents the population distribution of the number of hours studied. The other 2 are sampling distributions of the average number of hours studied X bar, one for sample size n equals 5 and one for sample size n equals 50. And we ask students to circle the most likely distribution for each population. So I'll give you a couple moments to kind of think it over and maybe think aloud to yourself as you look at these answer choices. All right, so let's go ahead and go through the answers. So the population distribution was graph B. The sampling distribution with n equals 5 was graph A, and then the sampling distribution with n equals 50 is graph C. And so what we're looking for here is for students to kind of relate the sample size to the variability of the mean. If we could go to the next slide, please. So all 9 Think-Aloud participants that we gave this question to got it wrong, and only 1 student reasoned about the variance at all. And so I kind of want to take a moment to emphasize that if we hadn't done the Think-Aloud interviews, this is all that we would know. We would only know that students were getting it wrong, and we might conclude like, okay, they did not pick up on sampling distributions when we taught it. And you know, this would be a hard question, and maybe we would want to spend more time talking about the concepts behind it. But since we did do Think-Aloud interviews, we get a little bit more insight into what they were actually thinking about. Next slide, please. So we noticed a couple different trends in the student answers. So we had one group of students who were noticing the smaller sample size and then tried to match the n to the number of bars in the histogram. So they took the smallest sample size and matched it to graph C. And then we had another group of students who said something along the lines of, you know, the population should be normally distributed. And so they matched the population to graph A. And so these are two things that have, you know, nothing to do with sampling distributions, but were really some of the main drivers for students getting the question wrong. And so one of the things we advocate for in the paper is using Think-Aloud interviews to iterate on question rating. And so we set out to reword the question to narrow in on the specific concept we wanted to measure, which was that relationship between the variance of the mean and the sample size. Next slide, please. And so we kind of asked ourselves, you know, would students still get the question wrong if we explicitly state the sample size and remove some of the statistical jargon? So the revised version of this question is, Jerry, Steve, and Cosma are conducting surveys of how many hours students study per day at a large public university. Jerry talks to 200 students one at a time and adds each student's answer to her histogram. Steve talks to 200 students, 200 groups of 5 students. After asking each group of 5 students how much they study, Steve takes the group's average and adds it to his histogram. And Cosma talks to 200 groups of 50 students. After asking each group of 50 students how much they study, Cosma takes the group's average and adds it to his histogram. And so we've done 2 things here. We've explicitly stated that there should be 200 points in all of the histograms that we show you. And then we've also removed words like sampling distribution and population to try to remove that signal that was sort of sending students to think that something should look normal. Next slide, please. So the next round of interviews, when we gave our revised question, 9 of the 12 participants answered the new question correctly. 5 correctly referenced the normality or the spread of the means and said something like taking the average of a larger group should lead to the means being all bunched in one place. However, 3 students who got the question right had still misread the question and thought Cosma had 4 groups of 50 students. And so they still said, oh, smallest number of groups, and so I'll match the number of groups to the number of bars in the histogram, and they chose C. So even though they got the question right, they were kind of still doing that sort of histogram misreading. And then one student who answered incorrectly matched Cosma's larger group of students with graph A because it looked more normal. And so the trends that we were seeing were kind of persistent in the second round of the question. But one of the things we talk about in the paper is some additional questions that we wrote to try to get at those issues specifically. Next slide, please. So this case study is really illustrative of what we think Think-Aloud interviews are especially useful for. You know, they give us a snapshot into student understanding of statistical concepts beyond correct or incorrect on questions. The student responses also helped us identify some unexpected misconceptions. So we weren't expecting to see that like histogram misreading in the responses to the questions. And we have some additional examples in the paper. We have a case study on the correlation and causation questions as well. And so, you know, we also really encourage the use of Think-Aloud interviews by other statistics education researchers, and we hope our paper is useful in getting started. Next slide, please. So thank you so much for your time today.
If there are questions, you're more than welcome to either use the raise hand feature or you can type one in the chat. I actually had one question. So did you have any difficulty with students not being good about thinking out loud? Because you said, don't interrupt them, don't let them do their thing. But I could see where some of my students would just kind of give me 3 words and that would be about it.
Yeah, so in fact, the only type of feedback we gave students at all was to just give them reminders to think aloud. And so if they kind of were silent for a little bit, we could see them sort of like mulling over, we would say, could you explain what you're thinking right now? Please remember to think out loud. And yes, it is hard. One of the things that helped was having students read the question out loud. So then they kind of like are a little warmed up in reading it. And kind of it feeds into them explaining their question process a little bit better. But yes, some students are definitely better than others.
Did you have a place where you got, I mean, I know you said you wrote a lot of questions. Did you have a place where you might be able to start if somebody wanted to do this? At least have some good example questions, not necessarily ones they would use, but a place to start.
Yeah, so there are a few good sources of questions I think people should consider if they want to, learn about what their students are thinking. I suppose it depends on the course and the topics you're covering. So if you're covering a particular subject, if you just use, old exam questions, things that you expect your students to know well, some of our questions, like the one we showed, were old questions from the course. Another good opportunity or a good option is for topics that there exists a concept inventory for that someone's already drafted that's meant to get at sort of conceptual understanding of these topics. It's good to look at those questions, see which of them are applicable to your course, and build on them. A number of our questions, original draft questions, came from CHAOS, the Comprehensive Assessment of Outcomes in Statistics. And then we tested them on our students and adapted them, revised the questions accordingly following our process. So you can get them from a variety of places.
Yeah, I actually used CHAOS in my own dissertation research, so I thought I recognized a style of question there. We do have a raised hand. Maria Tackett, let me try that. I think you can talk now. You might have to unmute though. Maria, you there?
Oh.
All right, maybe not. All right, were there any other questions? Not seeing anything in the chat at the moment. Sherry Johnson, let me see if I can pull you up there. I think you should be able to unmute and talk.
I think I just unmuted. Can you hear me?
Yeah.
Yeah.
Awesome. Well, I applaud your efforts on getting to more of the qualitative side of things as opposed to, I know there's, I recently finished my PhD in mathematics education with a focus on statistics education. And when I initially started there, I was like, oh, good, I get to crunch all the numbers, and come to find out that UGA is really known much more for their qualitative research of things. So, so I actually used a lot of Think-Aloud interviews for the research that I did. And I think this is a great way to introduce it into creating better questions. I have 2 questions for you. First of all, did you do anything? I know you said you pretty much only asked the student what they were thinking if they were quiet. Did you do any work on creating any like interview protocols at all?
Do you mean like probing with follow-up questions?
Yeah, or considering other questions or other approaches that students might use to answer questions.
So we, during the Think Aloud portion, so Ciaran talked about sort of a 30-minute Think Aloud portion, we didn't do any sort of prompting or probing of the students with additional tasks or things beyond just the questions we were going through. At the end, what we did do in that debrief period is go back through, and if we weren't sure why the student did something or they made a comment that was worth following up on, we would go back and ask them about that. That wasn't really a structured, like there wasn't a flow chart describing how we were going to do that. That was just, we went back through the notes and went through the questions with the student just to make sure we understood how they did each thing.
I think that's a really nice touch. You don't often see that in a lot of studies. I also have read some stuff, and I've actually tried in my classroom too. I developed a statistical reasoning class at a independent school, high school level, and have read some stuff and tried some Think-Aloud interviews with my actual students. Have you thought of implementing that at all? Like, after seeing the reasoning that you're uncovering, is this a way that could be either a formative or summative assessment that might get at the deeper understanding of the students?
I guess two answers. Let me give one and let Ciaran give the other. I have a flippant answer, then I see Ciaran was going to give the other one.
Yeah, it depends on the class size.
Yeah, well, yes. Well, one answer is, I think it's definitely worth doing some interviews with your students informally, maybe not as a research thing, just because we realize so much about what our students are thinking we had not realized despite having taught them classes before. Just the degree of insight you get into what the students are thinking is not something that you get normally in pretty much any other context in a course, because you're usually trying to help the students, and so you're pushing them in the right direction, and you don't often see just how they do problems without you there. So we all kind of thought, everyone who teaches should be required to do this at least once just to see what it's like. Ciaran, did you have something about the assessment side?
I did, and Laura's actually just put it in the chat. Alison Theobald has a great paper that came out, I think, in the last year. Laura might have a better date for that in the chat, but in Journal of Statistics and Data Science Education, one of the last few issues, on using oral assessments in classes. And there's a little bit of a difference between an assessment and a Think-Aloud interview, because the purpose is a little bit different, right? The purpose of an assessment is to, maybe it's summative, maybe it's formative, but at some point you're also sort of trying to evaluate the student for the purpose of the course, as opposed to maybe getting a great sense of what that student's reasoning looks like. Oh, Laura's just put the link in the chat. Awesome, thank you. But one of the things that you'll see in the literature is people sort of being very cautious about assigning grades based on Think-Aloud interviews. And I think we touched on this a little bit, just because it does change the reasoning process a little bit. So you might get a sense of what the students know, but their actual chain of reasoning might change a little bit if they're worried about the grade, or if they're talking to someone who's actually evaluating them rather than just trying to capture the process. So I think that oral assessments can be really valuable, and Alison has some really good advice on those, but they are slightly different from trying to get a sense of what the student is thinking sort of from start to finish.
There was also a question, and Amanda, it looks like you're typing an answer, but I'm just going to go ahead and read it. Do you get any, in the question and answer session, do you get any sense of what happens with this approach as the complexity of the question increases? For example, if you ask a question about deriving the MLE of a distribution, or any other question that takes several steps, I'm curious about how the approach scales with the complexity of the question.
So you picked a fortuitous example there, taking the MLE. One of the projects that we've done after the interviews described in the paper, but we haven't yet written a paper about, was looking at student reasoning in our sort of mathematical statistics course that introduces MLEs and confidence intervals and sort of all the mathematical stuff. And we've actually done interviews having students take the MLE of distributions, things like that. And there's an approach that's pretty useful for those called cognitive task analysis. Essentially, when you have a more complex task, the hard part is trying to categorize and break down the student thinking into pieces, because students will do, they're doing the MLE, there's a whole bunch of stuff from taking the derivatives and solving to knowing the right distribution, interpreting all these things. And so it's helpful to essentially come up with a sort of list of individual pieces that are involved in getting to the right answer in that sort of question. And using that when you're looking at a transcript of the interview or sort of coding the student's response to break down their approach by which of the steps they're doing at which time, and then which of those steps they might have gone off in a different direction on. And also, you may find that your list of steps does not match how experts actually do it or how students actually do it, even when they're doing it correctly, which is also a useful thing to know. There's been some research on cognitive task analysis and training, which shows that often experts teaching a technique teach a particular set of steps, but then when they do it themselves, they actually don't follow those steps. They do it differently. And getting them to doing an interview with them, using that to build out the set of steps, and then teaching that to the students can lead to better outcomes. So I'll leave a link in the chat to a ECOTS presentation we gave about this a couple years ago, about sort of preliminary results of that work, if you're interested.
Not seeing any other questions, so I just want to say thank you to Alex, Amanda, and Ciaran for taking the time to share this with us today. There will be a recording posted on Cause as well as the slides in a little bit. So I hope everyone enjoys the rest of June, and we'll perhaps see you in July for the next webinar.
And thank you all for coming.